Hello guys, in this video we will talk about how to size solar power system you need for your house. First we will calculate number of panels we need. Then number of batteries. And inverter size we need. And finally the total cost of the system. Before we start, please subscribe to my channel. Consider we have the following data to design our system. And peak sun hours in my area is 5.31. You can check peak sun hour in your area via the link in description. And we have chosen this PV panels model that has following data. Now we will analyze the load to determine daily watt hours of demand. Assume this is my house. I have 5 lights, 2 televisions, a microwave, a washing machine and a water pump. Now we have to determine the energy that each appliance consume. Each one of my lights consume 35 watts, and I turn them on at night for 10 hours every day. So according to this equation the total energy consumed by this lights is 1750 watt-hours, and we will repeat that for each appliance we have. After that we can find total energy of demand daily, by summing individual energies, so the result we got is 6050 watt-hours daily. To find the total required solar power, we will divide total energy of demand into peak sun hours multiplied by efficiency of systems. Efficiency of the system, which is provided with datasheet in the design, includes the derating factor, efficiency of the inverter, AC and DC cable, etc. So the total solar power we got is 1520 watts. Now we can calculate required number of panels, by dividing solar power into rated power of solar panels, from PV's data sheet. So by dividing 1520 by 210 we get 7.23 panels. Of course we can't get 7 panels and 0.23, so we will choose 8 panels. We can determine how many panels should be in parallel by dividing charge controller's rated current into PV's rated current. From PV's data sheet, we will get 2.8. If we choose 3, then the total current of 3 connected parallel panels is 21.31 amperes, which exceeds the rated current of charge controller, so we'll choose 2 panels in parallel and 4 in series. And our panels connection will be like that. For the parallel connection, the current is 14.24 amperes, which is less than rated of charge controller. And for the series connection, the voltage is 177 volts. To calculate the bank of batteries, first we have to convert each appliance's AC power to DC power. For example, we will convert the power consumed by 5 lights, which is 175 AC watts, to DC power. We will divide 175 watts by inverter's efficiency. The result is 218.75 watts DC. We will repeat same process for all appliances. After that we will use the battery's bank equation. Note that if we have an appliance that operates during the day, and the operating hours is less than the peak sun hours, we don't need to use them in battery's bank equation. Therefore we eliminated washing machine and water pump. So we have 99 ampere-hours battery bank. To calculate number of batteries in parallel, just divide battery bank by batteries capacity, then we will have 1 battery in parallel. To calculate number of batteries in series, divide system voltage by battery nominal voltage, then we will have 4 batteries in series. To calculate inverter size, just multiply total AC power by safety factor, which is 25% by default. And here is our final design, producing clean energy. If we take average rainy days into account, then we should revise the equation for calculating solar power, with rainy days in the week. The new equation will be, if we have autonomy days, then we should take this into consideration while calculating the required battery bank. The new equation for battery bank with autonomy days will be. In next video we will talk about estimating the total cost of the solar power energy. Don't forget to subscribe our channel.